Okay. So everybody, okay. So today we have a very special TAO talk. Okay. And I guarantee you that this TAO talk will change the way you think about our lives and our existence on this planet. We often hear of the miracle of life, but this talk will use science to show us that it's not just a miracle, but rather a series of seemingly countless miracles that have taken place in order for us to be here. Tonight's lecturer is from Las Vegas, Nevada, Bill Krause. He's a retired aerospace test engineer and avid astrophotographer, which he says is not just his hobby, but his obsession. At the end of the talk, he'll share with us some amazing photos he has taken of space. He's also a veteran of the US Navy, where he was trained in the field of electronics. And he's also been a high school teacher and a private school teacher. And since 2003, he's been a TAO lecturer. So he's very good at explaining difficult topics in an understandable way. So during the talk, you can type any questions you have in the chat room, and we will ask Lecturer Krause for you. And at the end of the talk, we have a Q&A where you can ask more questions and share your thoughts. Okay, so without further ado, let's welcome Bill Krause. Okay, 1 second.
There. Okay. How about this? Can you hear me now?
Got you. Yeah, got it. And yes, you can share your screen when you're ready.
Okay. All set. Okay. Now, before I begin, I just want to bow in 3 times to our family altar so that I can have the help of the teachers and all the patriarchs and matriarchs in the grace of heaven to help me to become a better lecturer and to do a better job of explaining. So give me 3 seconds. There. All right. Now, I'm going to start this lecture, and this lecture is called Can We Really Exist Without Doubt? The physical reality of this. So, now, introduction. Now, let me just say that, let me get this out of here. There. Okay, this lecture proposes...
Bill, sorry to interrupt. You have to share your screen when you're ready. Your screen.
Pardon me?
We can't see your screen. You have to share the screen.
Wait a minute. Okay, hold on. Let me back up here. I thought I shared it right here.
Also, in the meantime, everyone, you can type your nation into your name so we can know where you're from. Okay, Bill, we got it.
Okay, you got it. And let me start all over again, okay? Can we really exist without doubt? The physical reality. let's look at that question. So, as an introduction, this lecture proposes a theory that we, as a species, could not exist without the help of a higher power. That higher power has many names: God, Allah, Yahweh, true nature, Buddha nature, Valley Spirit, you name it. But we choose to call it Tao. The following is a list of events that could have shaped our existence or not from the very beginning of time. So let's look at this. Consider this lecture is not forwarding any new concepts to the controversy between evolution and creationism theories. These are enough. There is enough going around about these already. So we don't need to talk about that. Was the Big Bang just an accident, random activity, or was there something to cause this event? Was the formation of the sun 4.8 billion years ago coincidental, or was it planned? Is the position of the Earth in the habitable zone or the Goldilocks zone just luck? Was the near destruction of the Earth just 4.5 billion years ago just a crapshoot, a roll of the dice? The near extinction of life on Earth 5 times in the past, something of a hit or miss event? Was the total extinction of the dinosaurs 65 million years ago a setup for the creation and evolution of all life today? These questions are many more, and many more, I'm sure, will be presented and hopefully explained to the listener's gratification. Again, the data presented today are facts with evidence to support them, or until other theories come along. Any questions so far? We're good to go?
Good to go.
Good. The first cause, the Big Bang, occurred approximately 13.7 billion years ago. It was a point in space, and underline space, quotation mark, called a singularity. It was infinitely small and infinitely massive. And by using undefined words like infinity and infinitely, meanings that they are undefined. How small are they? Don't know. How massive was it? Don't know. But it was truly infinite. This figure is based on observations of special stars. The figure I'm talking about is the 13.7 billion years old. Now, these special stars are called Cepheid variables. This works fine for approximate galaxies. For nearby galaxies, about 500 million light years away. Observations of individual stars are required for accurate measurement. Now, another observation method for greater distance is called the redshift. The greater the redshift in the object's light spectrum, the greater the distance. That's why we are going, or NASA is launching the James Webb Telescope. It will look at areas in the infrared, in the light waves and frequency below visible light. So we can look further into what we would call the past, but what the astronomers and physicists and astrophysicists would say, they're looking into the past of the Big Bang. How far back is the actual shift? How far away are these galaxies? Now, we know Now, how time and distance is related. Now we return to the first question. What is the Big Bang? The Big Bang is the eruption of that singularity we talked about, causing the formation of the universe. Now, definition time. What is a singularity? And we bounced upon that a little bit. There's a point in space-time in which gravitational forces cause matter to have infinite density and infinitesimal volume, with space and time becoming infinitely distorted to a point of non-existence. At the time when this singularity was present, there was no such thing as time. Time did not exist. There was no such thing as time. It was just there. And this is just an illustration of what the Big Bang might have looked like. However, it's a little bit cheesy. Now, 1 picosecond. Now, a picosecond is 1 times 10 to the minus 12 seconds. So that means there's a 1 with 12 or 1 with 12 zeros in front of it to the decimal point. So it's very, very small. Now, 1 picosecond after the Big Bang, the unified theory began. All forces were at that time one, then separated into 4 distinct forces. The formation of the universe from the very beginning had an order to it. This order is the 4 forces, as mentioned above in nature. Weak, these are the 4 forces: weak, strong, electromagnetic, and gravity. The order and expansion is governed by the weakest, but the most pervasive of all these forces, gravity. So weak and strong forces are contained within the atom itself that holds the atom together. All the neutrons, electrons, protons, they're all held together. Now remember that the protons and neutrons are made up of smaller, yet smaller particles. The quarks, the bosons, the bosons, the mesons. Let's see, and also in theory, the Higgs boson. So that's something else that is a little bit beyond what we're talking about here, though. To illustrate this phenomenon, the following display shows the time of the Big Bang until present day. Now, as you can see here, right at this point here, oops, back up, sorry. This point right here, the Big Bang, in the infinitely dense moment, 13.7 billion years ago, the universe was born from a singularity. And scientists and engineers and astrophysicists have dated this number to 13.8 billion years now. And that just occurred about a year or so ago. This slide's about 3 years old. Now, that's the first thing right here. This is, come back here. I forgot to get the pen. Okay, right at this point here is the Big Bang. Now, this is called inflation, where the expansion of all matter from the actual Big Bang has gone out. Now, here we have the mysterious particles of force accelerating the expansion. Some models inflate the universe by a factor of 10 to the 26th power. So that means it's a 1 with 26 zeros following it in less than 10 to the minus 32 seconds. So that means that in this period of time, matter and energy is being inflated or expanding at a tremendous rate. Now, after about 380,000 years, things start to cool down. So now remember one point, this point here is an inflation. The temperature in this inflation is measured in the billions of degrees Kelvin, billions. And so as you know, as the more active the atoms and molecules are, the higher the temperature. So it means that these things are just whipping around like crazy. Now, after 380,000 years, things start to settle down. They start slowing down and cooling off. Now, at that point, we have clouds of dark hydrogen gas cool and coalesce. So that means hydrogen starts to form during this, right after the 380,000 years. And it's to a point where this point right in here, you can see, becomes light. Light becomes, how should I say it, visible, but light is formed, and light is basically photons being generated by the change in the different orbital ranges of the electrons around the nucleus of hydrogen, and helium too, because helium is also part of this. And so they rotate, and when they change from one level to another or in positions, they give off what's called a photon, which is a particle of light, but it's also a wave. So that's what what Einstein came up with. So it's a particle of light and wave. And after that, in this particular area from here on out, galaxies and globular clusters, dwarf galaxies, the stars basically are formed. And now to this day, they're still forming. Give you an example, I have a picture of later on of the M42, and M42 shows stars being made there. Hubble telescope has showed a couple of protostars with an accretion zone around it, an accretion disk forming planets. Interesting, it's very, very interesting. I don't have that picture, but I do have my own picture. Now, oh, by the way, are there any pictures or any questions so far? Okay, moving on. Another factor that has raised its head is a thing called dark matter. Little is known about this elusive stuff, other than it's keeping the universe continually expanding and at an ever-increasing rate of expansion. Now, if I could go back to this one, notice the shape of this. It's almost like a bell. See this shape? It follows this shape. Now, that means that from here to here, it has expanded. The universe is expanding faster than it had been from this point to this point. This versus this. You can see the physical differences between them. And so this expansion is continual, and it's caused by dark matter. Now, also, there's another elusive element called dark energy. This energy has been theorized, but yet unproven through scientific evaluations. However, this energy seems to be forcing the galaxy or the universe to continue to expand and at an ever-increasing rate. This discovery has only been within recent years, so not much is known about it. Now, there is some evidence, call it circumstantial, not direct, but circumstantial, based on what they call gravitational lensing in far-flung galaxies. So there is some evidence of this lensing and consequently the bending of light from the galaxies that are beyond the galaxies that are causing the light bending by gravitational and lensing. So suspected dark energy creating that lensing. but it has not been absolutely proven yet. It's just one conclusion that has been proposed. Now, I submit to you that there are factors at work here that are beyond our limited knowledge and experience. Again, dark energy, dark matter. Dark energy contains 76% of all things in the universe. Dark matter is 26%. That means what's left over is what we see in the sky at night. That's what's left over. What we stand on is what's left over. It's only about 5% or so. So there's not a whole lot there. So there's a lot of dark energy, there's a lot of dark matter that we just cannot observe, not yet anyway. Now, problems still exist if something had to have pushed the start button. Something had to have organized this Big Bang. Perhaps we must rely on the philosophers rather than scientists to answer this question. Now, scientists and astrophysicists have generally agreed that the Big Bang did happen, but the argument arises as to what started the Big Bang. There are no evidence to establish anything before this event. Remember that time did not exist before the Big Bang. Now, there is one person, Roger Penrose, who has proposed that it is a cyclic. It's not just one-time shot, it's cyclic, but he has no proof, he has no evidence of it. The only thing he has is what they call the CMB, cosmic microwave background photograph, but it's not conclusive. And he has not proposed that this did in fact happen. It's just a theory, something that of many different theories about what started the Big Bang. About 4.8 million years ago, gaseous nebulosity began to rotate, condensing the gas. Gravity has hard at work forming the hydrogen gas into a ball until the spark of fusion began, and the gas ball turned and formed into a star, our sun. Now, remember that there are two different types of atomic energy sources, one called fusion, the other called fission. We'll look at the fission later, but fusion is basically a gathering together of molecules and compressing them together to form larger and heavier elements. In the core of the sun, the pressure is so great that the forces are combining the hydrogen gases into helium. And then that function creates heat, energy. So it takes 365 million tons of hydrogen to form 360 million tons of helium, with 5 tons given off as energy. So that's an old figure. So that might have changed since then. But it is true that this has changed a considerable amount. And all stars do this. They all create fusion, and they all create different elements within. As a star ages, the elements change. Hydrogen forms into helium. Helium forms into lithium. Lithium forms into oxygen. Oxygen forms into nitrogen. It gets down to a point where iron is there. And to fuse iron, it will take more energy than the energy given off by that fusion. And therefore, that particular star implodes. It falls into itself because the balance of gravity versus energy output has now shifted. Gravity now wins and creates an implosion. And now that implosion comes together, forming a tremendous amount of energy, and it then explodes. Hence, a nova, a supernova, a hypernova, all these different things, forming white dwarfs, brown dwarfs, neutron stars, magna stars, gravity stars, and black holes. So that's a real quick summation there. Now, the remnants of gas and debris left over from the sun's birth congealed into planets, both the rocky and gas giants. Note that the gas used in our sun's formation was a remnant of a long ago supernova, age unknown. When did it happen? Don't know.
Impressive.
Now, this photograph here shows our protostar, our sun here forming up, just starting to turn on. And these lines of dust and debris are actually what's left over from the supernova. And as you can see up foreground here, the collision of these smaller particles forming larger particles, larger rocks, pebbles, rocks to boulders to massive planetoids or meteors or asteroids, and thus creating this accretion disk forming all the rocky planets in the 4 positions from the sun out to Mars. And from there, the gases from those stars formed the gas giants. It was just, in fact, I just read something last night. It's hypothetically thought that the formation of the sun and the 4 rocky planets were created by a nova. However, another nova of close by, very close by, formed the gas giants, which is interesting. So there was actually 2 novas that formed the solar system. First nova for the first 4 planets, and the other nova was for the gas giants all the way out through the Kuiper belt and through the Oort cloud. So that was an interesting point that was brought up that I read last night. Now, the supernova that created our sun was considered a 2nd or 3rd generation star. The supernova blew up about 68 billion years ago, distributing its expelled gases everywhere. Gravity had a hand in it, also forming into this rotating ball, and turned on the light of fusion deep within the core of our new star, our sun. This is the only way that heavier elements can be formed. All elements beyond iron are formed in the explosion of a supernova. Remember that we are all made of this star stuff. We all are part of that supernova that went off 68 billion years ago. By the way, this is a supernova. This is a photograph of a supernova. It's called the Crab Nebula, and it's called M1. And within it, right in this particular area, approximately in this area in here, there is what's called a neutron star. Now, that neutron star is about the size of Manhattan Island in New York. So it's not that big. However, what is unusual about it is that it does have a point of radiating high energy particles at some specific location on that rotating star, to a point where the radio telescopes on Earth can measure that line of radiation. And they found that that particular star rotates at 30 times a second. Now, that is awfully fast for such a large body. So that particular neutron star is rotating at 30 times a second. Scientists have noted that, have seen the fluctuations in the output of energy from that particular star. So that is what happened to that star. The distance from this point here to this point up in here is about 10 light years. This occurred. You think, well, this happened many, many thousands of years ago. It didn't. It occurred in 1054 AD, noted by Chinese astronomers and Arab astronomers. So they noted that time and they saw this thing. This was one of the few objects that was bright enough to see in daylight. So there's three objects that you could see in daylight: the sun, sometimes the moon, and this particular explosion. This explosion happened, like I said, 1054, and it lasted that you could see it during the day for about 2 to 3 months. And after that, it faded away to what you see today. And this is a view of this particular supernova remnant from the Hubble telescope. I have a picture of this too, but you cannot see a whole lot. So I'm going to try to do a better job next time. Now, as the sun kickstarted itself, so too did the planets orbiting the sun. However, it was not just 8 or 9, but literally thousands of planetoids crashing into each other, forming larger bodies, increasing their gravity until they swept the surrounding space of almost all debris, leaving only 4 rocky planets and the rest as gas giants. This process is called accretion. And by this new theory I had read last night, there might have been 2 novas that went off, creating the 2 different groups at a different time. So there might have been a time difference between them. Now, the results of this space vacuum can still be seen as the 67 moons orbiting Jupiter and the beautiful rings of Saturn with its 82 moons, plus the asteroid belt between Mars and Jupiter. As the Earth took shape and stabilized about 4.657 billion years ago, an event occurred that was a near tragedy for the young Earth. At this time, Earth did not have a traveling companion. It was alone in space. There was no moon. However, a rogue Mars-sized planetoid called TAO struck the Earth with a glancing blow, almost destroying it. The Earth survived, but TAO was completely obliterated. The debris orbiting the Earth and through accretion formed the moon. And scientists and geologists have noted that there may be remnants of TAO in below the mantle of the Earth in certain areas because of the density between the two, between the Earth's rock and this planetoid rock. So there was a density. So it might have been caused by that. And there's still evidence of it existing today. So that's what it looked like. That was the impact.
Hindi, inay natin.
Now, the orbit of the moon was very close, about 15,000 miles from the Earth's surface. During this time, the Earth's surface was very hot, almost molten. And as it cooled, gases were being developed and condensed in the atmosphere, forming liquid water. Now, additionally, comets and other water-bearing space debris also struck the Earth, depositing water on the Earth's surface, forming large bodies of water. Many of these were happening at this time. Now you can see some of this right here. This is the hot Earth. These are some of the rocks, and this is the moon after the impact forming up into basically the moon. Remember the moon? Well, it seems that the Earth's rotational speed was very fast then. At this early time, the Earth's rotation was a shade under 20 hours. So the day to night was 20 hours, not like it is today at 24. Also, the moon was slowly leaving its orbit around the Earth. Okay. Today, the Earth's rotation speed is just a hair under 24 hours. 23 hours, 59 minutes, 4 seconds, ain't counting. Why the slowdown? Simply put, water. The orbit of the moon has slowed down the Earth's rotation from friction called the tides. As the oceans are attracted to the moon, so the oceans slow down the rotational speed of the Earth. Now, as the moon's orbital speed around the Earth continues to slow down, so the distance from the Earth to the moon increases. The increased distance is about 3.5 centimeters per year. This may not be much, but over billions of years of the moon's existence, it has moved out from 15,000 miles to a present distance of about 240,000 miles. This distance varies, this is an average, because the orbit of the moon is an ellipse. It's not a perfect circle. So there's a high point and a low point, an apogee and perigee. So it goes from 238 to 242,000 miles. Okay, so now you say, all right, so who cares? Well, the movement of the tides exposes land to sunlight and the elements of the atmosphere. Remember when that during the meteor bombardment era, the Earth was blasted by meteors? That's what created a lot of the water and moisture in the atmosphere and on land. Well, here, scientists and astrobiologists have speculated that these meteorites could have contained liquid water and a type of acid that could have sparked the birth of life on Earth. So, these exposures to the tides could, and I underline the word could, have triggered certain chemical compounds to form complex proteins. The building blocks of amino acids, which when placed together could have formed complex molecules. The RNA and DNA molecules, for example, from which life sprang from as we know it today. Now, DNA is present in all living matter, all living things. So everyone has an RNA and DNA molecules. That's the double helix. And particularly the upper level or upper forms of animal life, including humans. We all have it. And so this DNA gives life to these inanimate objects. So even plant life has a crude form of DNA. So that's how a plant can carry on, can reproduce, and have the same characteristics in its offspring as the parent had. Today we see the solar system as a majestic, beautiful, peaceful area of space where we live and prosper, right? Wrong. This is far from truth. Our peace is protected by our bodyguard, Jupiter. Jupiter and the other gas giants act as defensive linebackers in the game of space football. For those who know American football, there is a guy back there called a linebacker. He protects the quarterback. The Earth is the quarterback, and we have the linebackers back there to protect the quarterback, the Earth. Now, as an example of these defensive players in action was in July 1994. Jupiter was struck by 21 objects formed from the breakup of the Shoemaker-Levy 9 comet. The largest object striking Jupiter generated over 6,000 megatons. That means 6,000 million tons of energy. This is what it looks like. Here is one impact. Here is the second impact. Now, 21 impacts occurred, and they all went, here's another one up in here, it's just hard to see, but they all went on in this particular line all around the circumference of Jupiter. And this particular one, this one, and this one here, this diameter here and here, you can drop the Earth into that diameter, into that hole, and never touch the sides. And you can throw the moon in there as dessert because it will fit too. So you can see these were quite large. The well, I should say the remnants of this comet stripe are very, very large. So we can put an Earth right in there. Now, the size of Jupiter, if you look at it from here, this is the northern hemisphere, or a North Pole, if you would. And then the South Pole, opposite side, you can put 13 Earths here. You can just line them right up, 13 of them, all the way down. That's how large Jupiter is. So you can put 13 Earths from pole to pole. And so it's quite large. And you can see the size of these particular impacts here. Very, very large remnants of this comet. And a point to note, if this object was not intercepted and tackled by Jupiter, I would not be here giving you this lecture now. The Earth may not have survived this impact as witnessed 65 million years ago, during the reign of the dinosaurs. As a note, the Earth has gone through, like I said, 5 major extinctions, with the last one mentioned above, the 65 million year ago extinction. The extinction of the dinosaurs opened the doors for mammalian life to survive and flourish. Now, at the time of the dinosaurs, there was mammals living, but they were mostly underground animals, like rats were the precursors to the rats, rodents, shrews, and you name it, and some other smaller animals like that. And additionally, the comet that struck Jupiter was about 1.24 miles in diameter, smaller than the dinosaur killer of 65 million years ago, but nevertheless extremely powerful. Now, have you ever considered the position of the Earth relative to the sun and to other planets? Why do we have liquid water on the surface and the other planets do not? The Earth's orbit is the position called the Goldilocks position. Just like the fairy tale, Goldilocks ate the bear's porridge. She found one too hot, another too cold, but the one was just right. That's the Earth's orbit, just right. Not too hot, not too cold for water to be liquid. And the argument also comes down to, well, what about Mars? Mars, billions of years ago, did in fact have water on the surface. And it is witnessed by the formation of a stratified rock, sedimentary rock, and sedimentary rock has a unique feature. It is layered. So you can see the layers of different rock laid upon each other. And this was seen by a number of the space, not boards, but the Martian landers, Curiosity, Perseverance, Opportunity, and I forgot the other one, Independence, I think. So they all witnessed this particular type of rock layering, and it can only be caused by water and the remnants or sediments layering or laying on top of one another. And next time you go to the Grand Canyon, you can see that extremely well. you can see the layering within the Grand Canyon. You go to any rock formation, you can see it in the United States. Where I live, there's a place called Red Rock Canyon, and you can see that very prevalent. See the sedimentary rock and how it was formed from the ancient seas of 50 to 150 million years ago. And this is a nice, pretty picture of a peaceful solar system. I don't think so. Okay, 65 million years ago, there was a meteorite that struck the Earth in the Yucatan Peninsula. The evidence was found in 1978 when an oil company took soundings for a new oil field. They found the crater to be about 112 miles in diameter and about 12 miles deep. That's very, very large. The estimated size of the meteorite was about the size of Mount Everest, about 1 trillion tons. Just think of what the meteorite first made contact with the Earth. The other end, the opposite end, was still at 6 miles above the surface and still traveling at roughly 4,500 miles an hour. So it was really coming down hard and fast. So you can see this is what they've drawn it to look like. And that's about roughly the size. You can see in through here, this is part of the Yucatan Peninsula at that time. Remember, 65 million years ago, the Earth was not the same as it is today. So now this is what the crater looked like. This is the size of the crater. From this point to this point here, it's 112 miles across. And the center section right in through here, it's 12 miles deep. So you can see, and the shape of this crater is illustrated by the shape of this particular meteorite. You see this bulge here was creating this portion up in here. So it makes it very interesting to see that. Now, the resulting shock wave and firestorms consumed most of the Earth's vegetation and animal life, namely the dinosaurs. This was not the only thing. Other things created some problems that killed off the dinosaurs too, but this was the main cause. Okay, additional evidence is to support this discovery was made by a geologist named Walter Alvarez. He noted a boundary layer in the 65 million year level in a geologic formation. This layer would be called the Cretaceous Paleogene, or the KPG boundary layer. This layer is rich in a rare element or earth element called iridium. It is, and it's rare on Earth, but it is commonplace, it is commonly found in meteorites. This thus giving us a clue about what caused the demise of the dinosaur. Now, this is Walter Alvarez here, and this is his father over here. Okay, so this is father, and this is Walter. Now, here's the interesting point here. You see, we're talking about this KPG layer. Now note this. You see this line here? Down to about here. That's the KP layer. That's what they're looking at. The KPG layer is this layer of white material. And this layer is deposited, and it's about the way you can see the Walter's hand. So you can see it's probably about 8, maybe 12 inches thick, maybe not that thick, maybe 10 inches. But this layer was found, this layer here was found in Italy, in the mountains of Italy. So if it's 8 inches thick here, you can imagine what it was like in South America, Mexico, and portions of the United States. They have found layers of this stuff about 3 feet thick. The closer you get to the actual impact location. So this was layered all over the world. So this is why they call it the extinction time, because basically the sun was covered up by all the debris that was launched into the atmosphere by this particular meteor or meteorite. Witnessing that right here in Las Vegas, we have smoke coming in from Northern California from the fires there. And it gets so bad, we can't use our telescopes at night. You can't see the stars because of all the thick smoke. So that's one of the problems. And you can imagine for the entire world, the Earth's surface was covered with this. As another note, the fires in Northern California, Oregon, Washington, the smoke has come over and has covered portions of the East Coast now. So Boston is suffering from smoke from the Western California and Oregon and West Coast. And in Washington, and portions of Canada are also. So, because of this extinction 65 million years ago, it gave mammalian life a chance to flourish. Consider the scenario: if the gigantic meteor did not impact the Earth 65 million years ago, we humans may not exist today. We will be just a footnote in the history books of the dinosaur. Okay, on to this thought. We have been discussing the events of our little part of the universe. But what about other solar systems out there? Now, as of August 1st, 2021, astronomers have cataloged 4,801 planets orbiting stars other than our sun. Some are too close or too far away from their star to have any chance of bearing life or living organisms. Others are too close, crushing everything with their gravity. Okay. However, or I should say too large. However, there are a few planets that are in the Goldilocks position, just the right place. The count to this day is about 30 Earth-like planets in the Goldilocks position. These have the potential for life and possibly intelligence. These planets are what piques the interest of planetary science the world over. Do we have any questions now? Okay, moving right along. Now, quite recently, exploratory or exoplanetary scientists are becoming more and more depressed that they could not find many planets that met the criteria of Earth. The fact that there's only one so far that is just too big to have any speculation of life forming on it. This is called Kepler 452b. It's about almost twice the size of the Earth. Could it be our twin? Well, you figured that one. You figured that one out. Here it is right here. Now, you may be wondering, how is it that we are able to see these exoplanets? There was a telescope launched called Kepler, and it was positioned in looking at the area of what they call the Sagittarius star field, which is one of the arms of our Milky Way galaxy. Now, if you take your arm, hold it out at arm's length, and make a fist, this is the area where your fist is located. This is the area, so if you do it like this area is the area that this particular telescope was actually looking at. So it did not look anywhere else, just in that particular area. And it found 4,801 exoplanets. And like I said, there's only one, this one here, that may attract their attention. But there's 30 other particular planets that are in that particular Goldilocks zone of habitable zone. So far, we looked at the earliest times of creation, the Big Bang. We have observed the formation of our own star, the sun, and planets. We have addressed the formation of the moon and how it has benefited our existence. We have acknowledged that there were 5 great extinctions and discussed the last of them. We considered the far reaches of the observable universe and found other planets that may hold intelligent life. So the question is this: so why should I care? What does this have to do with us and Tao? Well, just about everything. Something had to kickstart the Big Bang. It just did not start on its own. The existence of the 4 forces in nature just did not happen at random. Something had a plan for this. Did the supernova that blew its top by coincidence, or was there a reason for it? Did the accretion of that star stuff forming our solar system just plain dumb luck? Was the impact of Theia with the very young Earth nothing but a roll of the dice? How about the position of the Earth relative to the sun? Just happenstance? The extinction of the dinosaurs was nothing but a mere encounter with a big rock? The possibilities of extraterrestrial life is just coincidental. What do you think has given the evidence today? Okay, let me redo that. What do you think, given the evidence today? Is it all random, as some scientists state, or is it something else? Or is there a force that is ever controlling all matter, allowing certain things to happen while preventing chaos from becoming the norm of the universe? Now, this force is something we are all familiar with. It is Tao. It has precedence over everything. That dark matter and dark energy are controlling the universe expansion, yet we don't know anything about it, just like Tao. We have now explored the events leading up to now. Scientists and engineers have given us ideas about how things happened in the past, but they have not given the reason why these events happened. Scientists and engineers only look at events through evidence and facts. As philosophers look beyond these dimensions to possibilities and potentials of why we are here. Consider this thought. It was about 300 years ago or so that man stepped away from the agrarian or farming culture and went into manufacturing culture. Consider this one thing: transportation. The advent of the Newcomen engine, the forebearer of the steam engine, was used to remove water from deep coal mines. Where did this thought come from? Where did this idea come from? James Watt and his idea went on to harness steam in stationary engines, ships, and later steam-powered trains. This was all started in the mid to late 1700s. In fact, one of the first steam locomotives was called the Stourbridge Lion, and that was built in the 1720s. The Industrial Revolution was in full swing. By the early 20th century, man was flying. People were communicating with one another without wires, radio, and people were traveling on rails and on pavement. The automobile has now become a servant of man. Science was now becoming a prime interest to all. Man looked into the heavens through the largest telescopes at that time and established the idea that things are constantly changing, not static as some people believe. Fred Hoyle is famous for the steady state theory, whereas the Big Bang theory was proposed by Edmund Hubble while he was looking at the Cepheid variables in the Andromeda galaxy in late 1920s from Mount Wilson, 100-inch telescope in Mount Wilson, California. The concept of the Big Bang had now arrived because of that. Okay, Einstein published this theory of relativity and his famous equation, E equals mc squared, that shocked the scientific community to its roots. Now, the formula E is equal to mc squared is the result of a tremendous amount of mathematical equations that were in calculus. So this formula right now seems somewhat simplified, but the calculus to derive that was quite immense. Now, as I was saying before, mid-20th century brought about the harnessing of the destructive power of the atom and its potential as a new source of energy. Now, this particular explosion was caused by a fission, a splitting of the nuclear particles. So in the subatomic era of uranium, they split the uranium atom, and this is the result, this tremendous amount of energy being expended immediately. And now the hydrogen bomb, which is hundreds of times larger, and it is splitting the hydrogen atom, which by the weak and strong forces have held those particular atoms very tightly to itself. So that's why the tremendous amount of energy being expended through a hydrogen bomb is much, much greater than the atomic bomb. Now, the three electronic devices also showed up on the horizon. Television, the computer, and the cell phone, commonly called the smartphone. These also came about. So the technological advances in the late 20th century is astounding. Now, where did these ideas come from? What put these ideas in people's heads to invent? It is truly remarkable, the advances in the last part of the 20th century. Too many to list here. However, could the inspirations of these inventions disappear, or were they preconceived? One more piece of theoretical evidence is as follows. This is called the cosmic code. In theory, and this is only a theory, there's no evidence of it, but the theory seems to say that it exists as proposed by scientists and astrophysicists. This also relates to the law of uncertainty. We cannot determine when one thing is happening at a particular time or location. So this is called uncertainty. Now, the governing effect in the universe is called the fundamental forces of nature. Okay, again, re-emphasize: strong, weak, electromagnetic, and gravity. The strength of these concepts is governed by these fundamental forces. Now, so accurate are these mathematical formulas to determine this that if the Big Bang were off, off by a factor of 1 to the 1 times 10 to the 14th power, that's 1 followed by 14 zeros, the universe as we see it today would not exist. Its expansion rate would not allow the existence of known galaxies to form, thus changing all that we know today. Even with the spread of matter being precisely calibrated, the events or the evenness of matter scattered throughout the universe would not allow the formation of stars. galaxies, and other physical phenomena. Matter needs to clump together to form stars. The precision of the matter clumping was also a meticulous process. If too much clumping, all the stars would form black holes, and it would not be enough. And if not enough clumping, gravity would be too weak to gather the gases together to form stars. So this is a very, very closely monitored or controlled environment where all these things happen just right. Now, even though we have exacting elements of a star and galaxy formations coming together, that still does not guarantee life formation on Earth-like planets. The processes are complex. Stars have to form not only helium from hydrogen for energy, but also the star's core must form heavier elements like carbon and oxygen. Some of these stars explode, supernova, creating these heavier elements all the way to uranium. And uranium is the heaviest naturally formed element in the universe. There are heavier elements, but those are all man-made. Nobelium, Einsteinium, Californium, all these plutonium, these are all formed from the uranium and addition and fusion of these particular elements together. The remnants of these exploded stars start new stars, and the process begins again. For example, our star is either a second or third generation star created from the tailings of previously exploded stars in the far and distant past. Remember that if there was a very, very slight change in the physics or physical processes, we wouldn't be here discussing this at all. We would simply not exist. So we exist not because of science, but because science follows a code that was created at the time of the Big Bang, and maybe before. And this code is without flaw. Could this be a form of randomness, or was there something behind this creation process before the Big Bang? Consider this theory and dwell on it. Is there a direction or guide that is giving us inspirations, concepts, ideas that show us how to better ourselves technologically? Is there some methodologies that illustrate a control, an order to all? And these technological discoveries are in themselves a way of achieving this insight to our own fate. Yet there must be something in this universe that not only created it, but also controls it and gives us life to all who occupy it. I'm speaking of the one power that is responsible for this. It can go by many names, as we looked at in the first couple of slides. But the one bottom line element is that we must acknowledge it. We must say something like that does in fact exist. And this power, this force, is called Tao. From the very beginning, from the time of the Big Bang to now and beyond, we observe the structure of Tao, the laws of nature, if you would, but Tao is definitely the power behind the laws of nature. In other words, Tao is nature and all the laws dealing with it. A large number of scientists and astrophysicists have argued this conclusion that physical reality is governed by itself. Yet, when asked, where did the universe come from? Their answer would range from a blank stare to a concept that everything came from nothing spontaneously without the hand of God or Tao being involved. Really? You decide. This is something for you to consider. all of the people who are watching this, consider this, look at it. Do you think the universe came about spontaneously? It just occurred, it just appeared, bang, there it is, okay, we'll continue from here. Or was there something else that created it? Something else that put the spark of creation and of this physical world and universe to our, and is it to our benefit, by the way? We see everything in the sky at night. Is that there for our own benefit, or is there other things going on there that we aren't aware of yet? So it's interesting that the government has finally came up with the thought that, gee whiz, UFOs exist. Well, do they? They say they do, but are they? There are outer space creatures, extraterrestrials. Really? Are they? Think about that. The last illustration to be presented is a photograph that came from NASA. This photograph, compiled in 2004, showed, could be titled one of the greatest images ever taken. This image was taken over a period of 11 days. It took 800 separate exposures from the Hubble telescope. These exposures are shot in black and white, the only way the Hubble can take pictures, with different color filters used. In each exposure was about 20 minutes in length, so about 20 minutes per exposure. Now, this picture shows what appears to be stars, but a closer examination will reveal that each patch of light is a galaxy. Some of the red smudges are at a distance of 10 billion light years away. Please observe the famous image from a patch of seemingly empty sky south of the Big Bang. Or I'm sorry, south of the Big Dipper. There are approximately 6,000 galaxies shown.
Impressive.
Now, this may be the only star in this whole picture. Everything else is a galaxy. From the largest ones you see right here and here, and this irregular shaped galaxy here. This is actually called it, it is a irregular shape, but it's a, okay, this guy down here is called a, this one here is called an elliptical. This is a spiral, and same way with this one and this one. These are all spiral galaxies. This is an elliptical, and some of these other ones, like, well, let's see, here and here, no, and here. These are all are called irregular. The reason why they're called irregular is because they haven't had enough time to form into one of these types of galaxies, into a spiral or an elliptical. So that's what makes this interesting. You're looking back into time. You're looking up to 10 billion light years in the past. Here's a close-up of some of these irregular galaxies. You can see the color. Now, remember I was telling you about the James Webb telescope? The telescope will be sensitive to infrared, the light that is shown that could possibly be coming from areas like in here. You see nothing here, but that telescope might be able to determine that there are galaxies in this area too. Now, this, so go back to this particular picture was taken. If you hold your hand at arm's length, look at your small fingernail, your baby fingernail, hold it up like this. See? Now, and you hold it up into that area. That is the area that you're looking at. That is this particular area, that area of your fingernail. So, and your fingernail is a lot larger, is larger than this particular area. So you can imagine what this would look like. As you can see here. Now, okay, now you have just witnessed the beauty and majesty of the Tao. This awe-inspiring image is just a microscopic view of the universe. To photograph the entire sky in this manner would require a period of 1 million years. And all of these images would reveal about the same density of stars and galaxies. A conservative estimate of the number of galaxies in the total universe is from 125 billion to over 1 trillion. And that's galaxies, not stars, galaxies. Our galaxy is a medium-sized galaxy. It's not something that's great. Our galaxy contains from 3 to 500 billion stars. The Andromeda galaxy, which is about 1.5 times larger than Milky Way, contains 1 trillion stars. 1 trillion. And there are other galaxies that are even larger. So they contain even more stars. And the number of galaxies can go up to as high as 1 trillion. That's an amazing number. And to think that we are the only intelligent life in the galaxy, boy, that's kind of an arrogant statement, I would think. But so you see how all of this stuff has occurred, all of these galaxies. And the galaxies are not just strung out in random, they are associated in groups. There are groups called, our galaxy is a member of the local group. There are 36 galaxies in our local group, and that's within 5 billion light years. So let's see, the Andromeda is 2.5 billion or million light years away. Triangulum, which is the third largest galaxy in the light group, that's 3 million light years away. Next one would be the small or the large Magellan Cloud, that's 600,000 light years away, and so on and so forth. And then there's a lot of smaller galaxies. Now, our local group of 36 galaxies is a member of the Virgo supercluster, which has hundreds, if not thousands, of galaxies contained within it. Now, all these galaxies, if you look at them, are actually looking like a spider web of groupings, of clumps of galaxies. And then there's a relative void of galaxies, and there's another clump. And you can see that they are connected through lines of galaxies. So it's not just boom, 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 boom. They are actually tied together through what they call a spider web of galaxies, connecting all these massive clusters of galaxies. It is truly amazing, the design and the construction of this particular universe. Now, as a point, some people say, well, how wide is the universe? Well, we know pretty much that the universe age right now is about 13.8 billion years old. However, if you go from edge to edge, the galaxy, edge to edge of our universe, and it is something like 92 billion light years across, 92 billion light years across. And people say, well, how can that be? That makes it older than the oldest star we see. Yes, because we're only looking in one direction. We don't see as these stars accelerate away from us, getting away from us. So, oops, what happened? So the stars are leaving, are separating, and this distance, because of the acceleration of dark matter and dark energy, is creating a larger and larger distance. It right now is at 92 billion light years across and expanding faster and faster every day. And so that's what's so amazing. And now, as we conclude this science lecture, we should be reminded of the power that Tao has not only over us, but the entire universe and all that it contains. Before we conclude, I would like to humbly show some of my work of astrophotography, photographing deep space objects, what we call DSOs, with my equipment. And I leave you with this wish. And that I'll be with you always. And if I made any mistakes, I ask you your humble forgiveness and the forgiveness of our patriarchs and matriarchs and all the our teachers and the grace of heaven. Thank you for your kind attention. I do appreciate that. Thank you. Are there any questions, by the way? Can't hear you.
Yes, there's questions.
Hi, Lecturer Krause. We actually have a couple questions. That was a great lecture. The first question is from Jason, and his question is, are we physical or energy beings of thought? One more time, I'll repeat the question. Are we physical or energy beings of thought?
That goes beyond what scientists and engineers and physicists think. Remember, they're basing everything on physical reality, on evidence of what they can see, what they can judge, and what they can mathematically derive from the evidence that they have. What you're talking about is something that philosophers would be looking at. Now, would we be energy? Yes, we would be energy. We would be physical and energy combined. How else are we surviving? We generate energy within us because look at the chemical reactions we have contained within us to maintain body temperature. Go and you see our body temperatures are pretty much at a certain particular temperature. This is caused by the energy created by chemical reactions within our body. So we have this particular thing. Now, thought. What is thought? What is thought? What is that? It could be considered an energy also. Now, some people say, well, we have 5 senses in our, okay? We see, we hear, we smell, we taste, we feel. However, there's one more point. There's one more sense, and that's the sense of our mind. All of these sensations that we derive are nothing but chemical stimuli, aren't they? We feel something, okay? because of the impact of a particular object on our fingers. Or we hear something because it reacts to the sound waves react to our nerves and our oral, how would I say, audio cavity. So this is what stimulates it. We taste something because again, that's a chemical reaction. So do we have an energy? Yes, we do. We do have energy. We do have, or considered to be a thought. So I hope that answers some of your questions. One question
Thank you.
anyway.
Okay, we have another question we'd like to share with you. Okay,
Sure.
so this is from SW. So the question is, what is the implication of dark when it, so I'm guessing this is referring to dark matter. Okay, so dark implies something unknown or unperceivable,
Wow.
or does it imply that there is no light particle? Thank you.
Okay, now this name of this particular matter and energy, dark matter, dark energy, are just a way of defining this particular entity. Now, it's just like when we define Tao, when we look at Tao, how do we talk? We don't know what it is. It's way beyond our grasp, our understanding, but we have to talk about it. We have to discuss it. We have to have some identity. So we give it an identity. We call it Tao. We understand what it is, but we can't put our hands around it. It's something that's just elusive. And yet we know it's there because it's within us. It's in our being. And so that's why. Now, they also call dark matter and dark energy. They just define it as something separate from the physical matter, the three different dimensions. So fourth dimension, just like Einstein said, he calculates that there's possibly 11 different dimensions. We can't go beyond the fourth dimension, time. So where about the other 7? I have no idea. He thinks they're there. He believes they're there. He calculates his math to be there. But what can you say? He can't get any definitions on it because there's no evidence, no facts about that. So that's why I say that dark matter and dark energy are strictly names are given to these unknown things. Again, they suspect dark matter because they have seen the lensing, the gravitational lensing that has occurred by the change in the light patterns around different galaxies, from further galaxies, and the light and the dark energy, they're still scratching their heads, but they have to give it a name, so they call it dark energy.
Thank you very much, Lecturer Krause. Now we'd like to have a sharing session. So Lecturer Robert Chen is going to lead the sharing session. Robert, are you ready?
Yes.
Okay.
So again, we want to thank our lecturer Bill Krause again for giving us a very wonderful sharing. We know that Tao is also the rule of running the universe. So if we're talking about Tao, we gotta talk about how the universe runs, how the universe goes, and everything from that. So we really appreciate how Bill dedicate his time to explain a lot of things to us, especially with his profound understanding of how the universe is guiding us to its current understanding for us. So really, once again, want to thank you, Bill, Lecturer Bill Krause again. And also at this time, I would like to invite people from around the world, which it's our members online now. So we'll go by country. So if anyone would like to share this time any feedback to our lecturer, Bill Krause, is welcome as well. So if anyone from India would like to share, like how you learn from the topic today, and if you want to, tell lecturer Bill Krause, feel free to use the time. Anyone from India? Just feel free to turn on your mic if you want to, speak. So if how about if people from, we also see people from Malaysia. Anyone from Malaysia would like to share? Yes, from Malaysia or India. Okay. I
Hi.
guess. Yes.
Hi.
Oh, hi. Hi, Sunny, I guess.
From Penang, yes. Thank you, Bill, for super informative sharing. As I know, when the way can be named is no more a way, and the path can be named is no more a path. So what is the ultimate reality of TAO?
Is that a question or?
So
Yeah,
you might
question.
repeat the last question you're gonna ask. What is the ultimate
Reality of TAO? Like as I know in Tao Te Ching, the 道可道非常道，名可名非常名。The name can be named is no more a name. The way can be named is no more a way. So what is the ultimate reality of Tao in this universe? Can you hear me?
Yes. So Sunny, let me help you rephrase. Correct me if I'm wrong. So
Right.
I guess you're asking that what is the ultimate relativeness about Tao? Is that your question?
Right.
Okay. Yeah, so he was asking that what is the ultimate relativeness of that? Yeah, he said the first
I'm sorry,
sentence.
I think it was ultimate reality.
Oh, reality. Okay.
Of
ultimate reality of Tao.
Is that a question for me then, Robert?
Yes, I think you are definitely a better person to answer.
Oh, the ultimate reality. That sounds like applying 1 + 1 and using calculus to determine the answer. It can be very, very complicated. The ultimate reality, ultimate meaning the absolute top end, there is nothing above it, and reality means what is there now. And the ultimate reality of Tao is that we witness a lot of the reality of its existence as circumstantial evidence. We see the earth, we see the plants growing, we see the animals out there, we have pets. These are all part of the Tao. These are all part of the ultimate reality of everything that has been created, everything that has lived and will live, and everything that has an initial beginning somewhere. Now, as I was saying about these remarkable deep sky objects, and within them, there are stars being created to this day. There are stars being formed. There are also stars that are basically dying. A good example of that is the reoccurring nova that's in a star constellation called Cassiopeia. It has made a supernova or a nova number of times over, and it's still visible today. And tonight, I'm going to go out and see if I can find it. So whether I can take a photograph of it, I don't know. It's magnitude 4, and with the clouds being what they are and the moon being out tonight, I don't know if I'm going to see it, but I can at least approach the idea that this particular nova is reoccurring. So the gases given off by that nova will eventually condense and form new stars. in a form just like our Earth did, like our sun did, like Jupiter and Saturn, Uranus and Neptune, they all did, and the Oort cloud and the Kuiper belt. They're all formed by a nova. So is that a ultimate reality? Everything is changing, and yet everything is the same. That's what the Tao Te Ching says. So where do we go from there? This is something that you have to look as an individual and to accept the fact that we are not here because of our parents. We're here because of what the Tao wants us. It is here because we now can help other people to understand what we know or what we think we know. Do we know everything about the Tao? Of course not. And I don't profess to know it. I'll be the first one to say, I don't know everything. I am very, very ignorant. That's why I'm always looking to learn more and more and more. So, but to say that the Tao is the ultimate reality, yeah, it would be the ultimate reality because it's the thing that's controlling us. It's the thing that created us. And it's the thing that allows us to survive and to continue on and propagate and not only here, but in other worlds too. The Tao is everywhere. So in the furthest reaches of our universe, out there at 10, 12, 13 billion years ago, a billion light years away, reality is there also. Gravity, a positive gravity on that particular surface will always make the object that you hold drop to the surface of that particular object. It always is that way.
Right.
The laws of nature are constant, always constant. So is there a distance or is there a place in the universe where you let something go and gravity will actually push it away from the object that you're standing on? That's a possibility, but laws of nature say, no, that can't happen. So, so that's the ultimate reality in my perspective. I hope I answered your question somewhat.
Well, thank you so much. I still have a doubt. Yeah.
Oh, okay.
Thank
great.
you.
You're welcome. My pleasure.
Thank you, Lecturer Bill. I just have Lecturer Krause. I just have to say one thing. Anyone watching on YouTube, you can enter the Zoom meeting room and you can share what you feel as well. Okay, the Zoom link is there. Thank you.
Hi, Derek.
Hi, Ryan.
Hi,
Ryan.
hi. All right. Can I answer this ultimate reality? To me, this Tao is the supreme force. You know, unseen, although it's unseen, but it is behind all creations and existence. Because it is so enormous, right? That it cannot be named, right? And but yet it must be named because for the human comprehension, right? Otherwise, Lao Tzu will not be able to explain anything to us. So with our limited intelligence and wisdom, so it is very reluctantly called Tao.
Yeah.
But the thing is, no matter how big Tao is, Tao still needs the assistance of humankind to not to exist, but to be relevant, right? Because there is a Chinese saying that the heaven and the earth, they don't have languages, right? So they need human to propagate it, to promulgate it as well. You see, which is why this thing Tao is made known to humankind, and nothing in the world can exist without Tao, right? So of course, like what Lecturer Krause say, nobody knows anything. I mean, nobody knows the ultimate truth about this thing called Tao, but yet we need Tao. The whole world, the whole universe needs Tao to exist. that is my humble opinion. Thank you. All right. All right. Does it answer your question, Sunny?
Well, just to speculate on that and to dwell on that, you're absolutely correct that without a commonality, we will not be able to understand anything. Commonality of language says that we have to be able to communicate to each other, and we must have a commonality of language. And by the Tao, we have to give it something so we can talk about it. So we give it a name, we call it Tao. What is it? It is the ultimate reality, if you want to say it. It is what is controls, what creates, what maintains us and the universe. It's not just us, it's everything, everything. And that's how the ultimate reality of the Tao permeates everything, not only us, but the universe in total. So that's another point. And just like you said, language is a very poor substitute for understanding of what the Tao is. But that's the only way we can express ourselves to have an understanding. Are we right in everything? No. But at least we can discuss it and expect to see or another person's perspective on that. And that's how we learn. That's how we advance. That's how we get to being a better person, by looking at the Tao as the ultimate reality, the ultimate control, the creator of everything. So, okay.
Okay, really appreciate Lecturer Bill Krause explanation and feedback.
Thank you.
To all of our people who asked the questions. And I also like to invite people from other one more person from from other country. So I invite Tian from Thailand to if you have any feedback or any question you would like to ask. Tian, are you here?
Tan from Thailand.
Yes, I am here.
Oh, hi, yes.
Hi, good evening, good morning, or good whatever it is. Good evening, everybody. Yeah. Actually, what you have shared with us, Bill Krause, thank you very much. I thought it's very interesting. It is very interesting for us to learn what you have done, what you have shared with us. But my questions, I have a question. How do you foresee, in terms of the scientists, about the world and the futures of the universe? Because I have heard that somehow the current world is getting bigger. Is that true?
The universe is expanding. Yes, it is. If you consider the time frame here being the beginning of the Big Bang, here is the present day. Now, it starts out at a large explosion. Boom, it blows up. Now, that expansion continues at a certain rate. However, because of the evidence or the circumstantial evidence of dark matter and dark energy, we're finding out through measurements of the redshift that the expansion of the universe is increasing. It's going up. So if the expansion of the universe, give it a number of, I'd say, 8 billion years ago, the expansion rate would be, and this is just a number, just as a talking point, of 10,000 kilometers per second, okay? Just as a value, just to give a point. Now, 8 billion years ago, today, 8 billion years later, that rate is something like 200,000 kilometers per second. So it has increased. Now, that value is just showing an increase. The actual numbers are, I have no idea. I have no idea about the actual numbers. However, they do know, scientists and astrophysicists and astronomers through observation with a number of telescopes and both land-based and space-based have indicated that because of the redshift, things are going away faster now than they did before. So that means that the energy, the dark energy and the dark matter is accelerating the universe at a faster rate now than it did half of its life ago. So if it's 13.7, so about a little under 7 billion years ago, it was going at a certain rate, and now it has increased. So that's what's amazing. What causes that? Don't know, other than speculating dark matter and dark energy. That's the only thing that could be creating this expansion of the universe. Now, what happens 1 billion or 1 trillion years from now? What happens? Think about that. Now, the universe is expanding and it's continuing to expand at a faster rate. There will be a time in the universe where everything will be so far away that light could not possibly reach other points. So we're talking the universe going completely dark because the light is only, it's a very fine, very small band of light. So we are only reacting to that very narrow band. So that's from 470 to 600 something. And that light band is only what stimulates our vision. Now, is there light beyond that? Absolutely, there is. But we have to determine that by different types of instrumentation. That's like I was saying, the James Webb telescope will be able to see beyond light into the infrared and possibly into the microwave. And that's why we have the cosmic microwave background. We can look at that and measure the temperature of the background, and it's sitting someplace around 4 degrees Kelvin. So, remembering that that temperature when the Big Bang went off was in the trillions of degree Kelvin. So you see it has cooled off considerably and has expanded out. And the expansion is what's causing the cooling. So eventually that cosmic microwave background will go away. It will approach and maybe very close to absolute zero, where all matter is supposed to stop moving. So we'll see what happens. I don't think that's ever going to be achieved, but scientists have gotten it really close, within a couple of millidegrees, but they have not achieved absolute zero, because then all movement of the electrons around the mass, around the nucleus, cease to exist or stop. And I don't think that can happen. My opinion is it can't happen. But that's just my opinion. I don't think it can ever happen. All matter stops moving. I don't think so. There's going to be some movement, always some movement around.
Okay. But what you have mentioned, it seems like the race is ahead of us, isn't it?
Yeah.
So this is what we need to cultivate.
This is only a guess. This is only a guess by scientists because they can't predict what's going to happen. However, they can come up with the data that they have presently, and by the expansion of the universe, it will continue to expand. It will not come back to what they call the big crunch. Roger Penrose says, oh no, it's going to come back, it's cyclic. Well, at the expansion rates going now and it's ever increasing, how can it come back from that when it's expanding away from us, away from all points at an ever increasing rate? It's contradictory. And again, it's theory. That's all it is, it's theory. Okay.
Thank you so much.
I've answered your question.
Thank you, Lecturer Krause. Robert, go ahead.
Yes. So thank you again. Thank you, our lecturer Bill Krause and Tim from Thailand. Yes, I feel like we have a very amazing flow with discussing all the, not just within the science, but we feel like having a science seminar, having a perspective within the DAO right here. And I just saw that we have questions and raised hand from Azu from Mexico. So Azu, would you like to share any feedback or anything you want to ask?
Yes. Can you hear me?
Yes.
Yes.
Hi.
Hello. Well, it was a pleasure and it was a lovely sharing. What I'd like to share is the Tao is present in all times and in all beings, because I learned that Tao is this force that guides how everything is created. So Tao is the way. So we should be really thankful for our existence and think of it not as a coincidence, but with divine or Tao purpose. And I think that's the way that we can accept and cultivate our true nature. So I learned a lot. Thank you very much.
Yes. And the thing is, there are different methodologies that are used. Some people speculate some types of creation of matter or things like that. And these are all speculation and different methodologies, different manners of which it's done. But it is done. However way it does, the Tao is the source. The Tao is what we look at as our source of everything, and is also creating or conditioning and controlling everything. This universe, yes, we have chaos in some areas. We have certain areas, just like my lecture said, that Jupiter is our defensive linebacker. It protects the inner planets. Sometimes it does, and occasionally one gets through. But most of the times it's caught by the massive gravity of Jupiter. And so it protects us. Now, here again is the Tao at work. And the methodology is the high gravitational attraction of Jupiter to other celestial bodies as it approaches the center of the solar system. So it's there to protect. Here again, the Tao is at work. It is showing the control of and protection of us from other objects coming out. Now, you may say, well, what about the dinosaurs being eradicated 65 million years ago? Maybe that was supposed to happen. Maybe that was supposed to be that way. Now, like I said, we had 5 extinctions where life has almost ceased to exist on our planet, and yet life survives. Why is that? The Tao is what is doing that. It is the thing that is providing us an avenue of existence so that we then can control and continue. Our control is our environment and also of our lives, using the Tao that's within us to guide us, to help us and other people. It's not just for us, it's for everyone. And that's how we look at the Tao. Okay, did I answer your question okay? Okay.
Yes,
good.
Thank you very much. Thank
Good,
you.
good. Thank you. Okay, Robert.
Okay, yes. Thank you, Bill and Azu, for sharing with us. And next, for our sharing now, I would actually like to invite one of our very special guests in our current class, participants. It is our Dr. Peter Pong, and he's online with us now. And I would like to give a little short introduction for our Dr. Pong, also known as our Master Pong. So many years ago, Transmitting Master Peng came to study in the US and pursued his PhD degree in the California Institute of Technology. After he graduated, he worked in NASA at the Jet Propulsion Laboratory JPL lab to continue his career as an engineer. So as many of you have known the Mars rovers over the decades of times, which we have been gone through 4 generations of it. So last year, last July, they launched the Perseverance to Mars, and it landed this February. And our Master Peng work, design, and test how the robot is gonna work when it lands on the Mars. And besides his job as an engineer in NASA, he also had been propagated out in many parts of the United States, including North Carolina, South Carolina, Florida, Michigan, and Chicago, and also many other states, just to mention it. So we're very happy to invite our Master Peng to say some words with us and just talk to us. So let's welcome Master Peng. Hello, Master Peng.
First, thank you, Robert, and give me.
Hi, Peter.
Hello, Mr.
Hey,
Peng.
Bill, my neighbor,
Peter.
very good and clear.
You did get up.
I did get up, and so I think first I want to say the Bill really gave a very eye-opening talk today. Yeah, and also that's why I set my alarm using my smartphone and wake me up. And, so I think I don't regret. I really enjoy your talk very much today. It's very enlightening.
Thank you.
And also very interesting. You give this kind of talk, almost like a modern physics, but in a very traditional temple. That's a very, very unique combination. Also, I realized Derek Claire and really set a very good platform, and so that we can unite all the dog brain in the world, so we can get together virtually and then enjoy enlightening talk and talk to each other. Yeah, and I think also the Robert did a lot of work behind the scene and make the whole thing happen very smoothly. Yeah, I really enjoy your talk and also give me a lot of enlightening thought as well. I think why we call the dark energy and the dark matters doesn't mean these things are dark. Just we cannot see it. Actually, we shouldn't say we cannot see it. We should say we don't understand it. Yeah. So when you don't understand something, you don't see it. And so sometimes you're reluctant to give a name. Just like 2,000 years ago, Lao Tzu, in his time, he cannot use Hubble telescope to observe so many stars, so many galaxies, like Bill just showed to us. But he just observed the nature around him. He can sense there's some force behind everything. And then he just gave a name, Tao. And today, I think the Bill also reached the same wisdom age as Lao Tzu. So that's why he can give us such enlightening thought. And also we realize there's a force behind everything. And then we cannot give a proper name. We just say that's the God. Maybe in other religion, they call it a God. But I think the Tao is a better word because God sometimes make us feel it's like a person there. Actually, it's not person. Maybe Tao, just like Bill mentioned, is a cosmetic law, cosmetic principle, or cosmetic code. Yeah.
Cosmic code.
Yeah, cosmic code. Yeah. And then also your talk give me some enlightening thought. And people say whether we are energy, matter, or something, and also our thought. I think this universe has a certain energy. What's that energy? That energy is called wisdom. The wisdom is energy, because if there's no wisdom in this universe, everything will happen randomly. There's no universe, no galaxy, no solar system, and also none of us. So there is a wisdom in the universe, make everything happen, not just randomly. They can happen in certain systematic, logical manner and make things happen. And the wisdom of energy, we call the TAO. And that energy also within us. We have that energy as well. Yeah, so when we call the TAO cultivation, means we're trying to cultivate that energy of wisdom within us, and then unite it with energy in the universe. And then we can become enlightened. When we really understand the universe, when we really reach that high level of wisdom, probably the dark matters and dark energy will not be dark. They will be bright. Yeah, let's continue to cultivate together, both inside and outside. And hopefully one day, beyond the pandemic, beyond this pandemic, we can meet each other in person and exchange our enlightening thought and ideas. So thank you, everyone. And I'm so glad I can listen to Bill talk and meet so many TAO members virtually. Thank you.
Okay. We would like to thank you, Master Fong, for your merciful words and those encouraging words. So we know that the topic that we're talking about is the universe. Now we're in the universe, but the universe is also within us. So by we're learning about TAO, acknowledge the TAO, the true nature within us, we're learning how the miracles that's happening in the universe. We're also using that pathway to help people also find a miracle within themselves. So that's really a very very amazing understanding. As we learn more about the universe, we're also digging in within ourselves. So again, thank you, Master Pong's merciful words. So I guess at this time, I would like to invite everyone, if you can, and please turn on your camera. We're going to do a group photo. Okay. So Derek and Claire, are you going to be doing the clipping for our photos?
Can you help us to do it?
Okay. So
Okay,
Okay, we got it here too.
Okay. Okay, so everyone, it's gonna take a while. So since we have
turn on your webcam. Thank you.
If you can turn on your camera. So we're gonna take a few pictures. Okay. All right, 1, 2, 3.
Sorry, I cannot open my camera.
Oh, it's okay. If you can, that's fine. But okay, we're gonna take the second one. Okay, let's do a thumbs up for this one. Okay, 1, 2, 3. All right, we're gonna take 3 more. Okay, this time, let me see.
That's right. Robert.
Yes, hold on. Yes, that's how about let's do
Can you invite Susan?
Let's do a victory. Yeah. Okay.
Victory.
1, 2, 3. All right, we got 2 more. All right. How about this? Let's do a little heart like that.
A little hard. Okay.
A little heart. Okay. All right. 1, 2, 3. All right. For our last one, let me think. How about let's go back to the thumbs up again, okay? All right. Okay, 1, 2, 3. Okay, all right. Thank you, everyone.
Thank you very much.
Thank you, Bill.
Thank you,
Thank you,
thank you.
Derek. Thank you, Claire.
Nice
Thank
to
you,
meet you.
Robert.
Thank you,
everyone.
Thank
Yes,
you.
yes,
Thank
yes.
you
Thank
very
you,
much.
everybody.
Thank
Thank
you,
you,
everybody.
Thank you,
Thank
everyone.
you.
Thank you,
Thank you,
Derek.
Nice
everyone.
weekend. Nice
You
weekend.
guys honored me.
People will go
Very
to
good to
bed
hear
and
you.
some people
Thank
will
you
go
very
to
much.
breakfast.
But
Yeah.
if
Thank you,
anyone
Bill.
wants
I will
Bill.
see you soon.
to see you soon.
Bill, I will see you and Susan soon.
Okay, Peter. We'll see you now.
Can I,
Take care.
And
Master
See
Parent,
you,
can I,
friends. All the best.
Mas-
All the best. See
Okay.
you.
Master Parent, can I say
If
hello to
anyone-
you, Master Parent?
Yes. Hello.
Master Parent, this is Ryan. Remember
Ryan.
me?
Yeah.
Hey. You
I think you
communicated through
gave
the.
a very good sharing today.
Oh, thank
have
you.
into the Tao.
Thank you. Thank you very much. So, Master Ping, are you going to teach us how to build a rocket or a rover sometime?
I think the rover just got some samples. So I'm working on the next mission, trying to collect the sample from Mars.
Really? Oh, so when is it coming back? When is this rover coming back?
Let me see, right by 2021st. I think we will launch the next rover to collect the sample, also launch a small rocket to send a sample back to Earth. I think that according to the current schedule will be 2026. Oh, actually launching in 2028, about 8 years from today.
All right, that's good. Looking forward to it.
I think at that time we all will gain more wisdom.
Yeah, of course, hopefully. Yeah. So are you based in the LA right now?
I'm in the LA and the Bill is in Las Vegas. And we see each other every few months.
Right. Do you go to Charleston?
Oh yeah, I see. Oh.
You
I think
go
there
to
are so many people.
Do you go to Charleston often?
Charlotte.
Oh, you
Charleston.
mean the where? The Charleston?
Yeah, that's right. You don't go that.
You mean where is the Charleston? Las Vegas or?
I don't know the one that you usually go, right?
Oh, that's North Carolina. It's called
Charlotte, North Carolina.
Carolina. I think the city is called Charlotte.
Yeah.
Charlotte.
I'm going to there this weekend, this Friday.
Right. Okay. I must have gotten this
And
wrong.
because
Sorry
of
about
Bill,
yeah.
Bill, I want to see him after my trip to North Carolina.
Okay. Yeah. So you are very close to Bill because you share the same astronomy science knowledge, right?
Yeah.
Yeah. Okay. So yeah.
And also, I want to share something. Bill has so much interest in the star.
Right.
And for me, I'm working on the aerospace engineering. I have a strong interest in the star space. I also have a lot of interest in the life. But the more you understand the life, you just don't believe everything just happened from evolution. You just don't believe it. There's a wisdom of the universe, make things happen randomly, but they happen in certain way with some purpose. We have to explore what's that purpose. Yeah,
that's right. That is the wheel of the heaven. Yeah.
I think this pandemic caused a lot of negative things, but a lot of positive things also happen. Because of the pandemic, we have more time stay home, and we can think, and we can see and understand what's happening really in our life and also in our universe. Yeah.
Yeah. So time for self-reflection. Yeah.
Yeah, I think after this pandemic, we all will gain more wisdom, also more weight too.
Yep. Thank you. Nice.
Thank you, everyone.
Nice
really love to see everyone. Yeah,
Thank you, Bill.
I have to go to my breakfast. Thank you. Bye
bye.
All right. Okay. Bye.
If anybody else would like,
see you soon.
Thank you, Miss.
Thank you, Derek. Thank you, Claire. Thank you, Robert.
Thank you. Cheers.
If
Okay,
anyone
bye.
has questions, can say.
I think if anybody else, the class is the main part's done, but if anybody else would like to stay and share, that's okay too. If Bill, do you still have time or?
I want to thank Peter for his gracious words of inspiration to me. I really am humbled by what he has said, that I actually give him inspiration and I use him for my inspiration. So it's really an honor to have these people talk and to accept what I've said. And I really, really appreciate that. And you too, Peter. Thank you so much. You know, you're just a wonderful person to know, and I'm honored to know you as a friend and as a transmitting master. Thank you.
Yeah. Also, we are not just friends; we are neighbors. Because my
we're neighbors too.
Yes, is across the street of Bill.
He has a house across the street from us here. Yeah. Which reminds me, I got pulled the weeds in your front yard. I got a complaint from the HOA.
Okay. You better do a good job. Otherwise, I will get a warning from the HOA.
Yeah, well, I already got the warning from you for you. So I'll take care of it today or not today, but take care of it this week. So no problem.
Okay, thank you, my neighbors. Thank you. I really think Derek and Claire and Robert, I think you really did an excellent job to set.
Thank you very much.
I think Derek has a lot of skill and knowledge about this kind of social media. And,
my wife.
Your wife? Oh.
Yes, on me. It's on me.
Oh. Wow, you are really a true DAO member. You give all the credit to your wife.
Thank you.
One thing I want to ask you, this is a technical issue because we probably want to do the similar thing in the LA. Right now you use Zoom. Do you have a limit on how many people can join the Zoom?
500. We have a 500. We had
that means that means you pay extra money to get 500 people.
Yeah, but not too much. We got a deal. So my wife got the deal. I don't know.
I think it's from the DAO Society from Singapore. They have a deal with the Zoom.
Wow. Yeah. If you have 500, that's why I wonder. Oh, you use Zoom. Your Zoom can only hold 100 people.
Yeah, if you need next time we can share our Zoom for you.
Okay. Okay. Oh, that's my biggest gift today because from time to time we need to have a Zoom to hold people more than 100.
Yeah.
And so we have but usually Zoom has another service I share with everyone online. You can pay extra just for 1 month, and then you can have more than 100 people, up to the 500 people, only for 1 month. So that's convenient.
Yeah.
If you want to have a platform like this, you always want to have more than 100 people every week or every month. You probably need to have a permanent license to get to hold more than 500 people every time.
Yeah. That is right.
Another technical question. Sorry, I asked so many technical questions because I'm so because I know you have very good setup. How you connect the YouTube with your Zoom?
Terry can share with this part.
That's easy. There's just a function. You have to have the stream link, and then you have to have the YouTube link itself. It's not too hard. That's actually quite easy with Zoom to set it up. That's not too difficult. It's there's a lot of information on YouTube how to do that too. There's so many videos that show that.
Okay.
By the way, sorry. Next week, August 28th, New York time, 8 p.m. They're going to share oneness of the DAO. if anyone interested, and we will share the link after with everybody, and you can leave your contact with us. Thank you.
Thank you.
That's a good title. That's a very good title. Okay.
Yeah.
Also, I noticed Derek and Claire, you are in a different room, right?
Oh yeah. We use one computer, one laptop, one cell phone.
Let's see. Wow.
Yeah.
So you are surrounded by all the high-tech equipment.
It's very complicated.
It is.
But you know, this pandemic really changed how we work, how we communicate, also even how we propagate Tao in the future.
Yeah,
You know,
For sure.
and force us to learn all the most advanced social media too, and then we found the power. For example, like today, we can talk to each other across the Pacific Ocean, just like using regular phone, and also we can see each other. This is amazing. Yeah.
So it's part of the Tao.
Change
Peter.
how yes. Hey, Bill, you
Yeah,
want to say?
it's part of the Tao. Yep.
Huh?
It's part of the Tao. That's how we can do that. Remember.
So we give all the credit to the Tao. So we are the
absolutely. Yep.
yeah, and we can share it all over the world, and then overseas people can listen to the Tao.
Yep.
Yeah, and also we connect all the enlightened mind all over the world.
Yeah, that's true.
Yep.
Okay. So,
sorry, I just want to say, is there anybody else who'd like to share that didn't get a chance to share before? Because there's a lot of people who asked a lot of questions. I'm just not sure if there's anyone.
Yeah,
now's the perfect time if there's anyone else.
Yeah, we noticed someone raised a hand before, but sorry we didn't have a chance to call you yet.
Oh, some hand.
Does anyone want to share or ask questions?
I think someone raised the hand. Panna Rachel Wang.
Yeah. Hi. Yeah, lecturer Claire, Derek.
Oh, hello, Rachel.
Hi.
Rachel Wang from Malaysia.
Yeah, I was late. Yeah, I was late, but I was really impressed with the photos. The photos of the galaxies shown by Lecturer Bill. So just wonder, I have sent a text about for my question about the photos. Can lecturer share about how he took the photos? What type of equipment that he mentioned? Yes.
Okay. Now, the first 3 photographs were done with just a Canon 6D camera, 25-second exposure, and using a 12 or 14 millimeter lens. That's all. Now, the picture of the let's see, the first one was a picture of the windmill. I used a couple of lights on the windmill to illuminate them. And then with the Milky Way and the Belt around, it was a 14 millimeter lens with a 6D camera. The second one was the rocks, and that was same camera, same lens. And I illuminated the rocks with the lights again. And the third one, I can't remember what it is, but well, I call the DSO, or the deep space objects or deep sky objects, are the pictures that I took with my telephoto lens, 600 millimeter lens, on a equatorial mounting space, or a star tracker. It's an equatorial mounting. And then the last one, which is M42, that one was a stacked on my 8-inch telescope. It's a RCA Ritchie Creighton telescope, 8 inches in diameter, 1600 millimeter focal length, on an equatorial mount, which is a CEM40. And that was a stacked group. I took, how many? I think I took about 20 photographs of that, and they were about 2 minutes in length, and I stacked them all together in a software program called Deep Sky Stacker. And then I went from there and moved it into a GIMP, and changed a little and emphasized some of the exposure levels, and it's called levels and curves, and it's a post-processing. It takes about a half hour to an hour to actually do the processing after the exposures. So, most of the exposures were done, the deep space objects were done with the 8-inch telescope. Yeah.
Wow.
Oh.
Wow, that sounds quite complicated, but it's so interesting. Yeah.
It sounds complicated, but it actually isn't. How should I say? It takes a tremendous amount of patience to do this because the setup and all the guidance and everything else involved. So it takes me about an hour before I can even take a picture to set it up. So for the telescope, for the camera, it's just a point and shoot.
Hey, Bill.
And everyone can take those pictures like that.
Bill, we don't have your skill and the equipment. We only have
that's true.
iPhone. How can we take a picture from iPhone? Teach us.
Yeah. So actually, I was thinking maybe you have waited like hours, in order to get the shot. They are so impressive. We just love the photos, and actually we have the Chronicle team for photography. Perhaps you can share more with us, no? So it's so interesting. Yeah. So we wish to learn more from you.
Oh,
yeah.
Wow.
And yeah, just one more. My sister has one question. Yes. Or would you mind to come over? I can't.
She's still shy.
Asking about the telescope.
Hubble.
What's the difference? What's the difference between the Hubble's telescope, Hubble Space Telescope, and the equipment that you use?
It's about let's see, the Hubble telescope is based on the same design as my telescope. They're both Ritchie Chrétien telescopes. And it's just that telescope in space is 90-inch mirror. The primary mirror, which is in the back, is 90 inches, and mine's only 8 inches. So you can see there's a factor of about 100 there. So, but they're same design. My telescope and the Hubble, they're same design. And I don't know what else I can say about it. It's a very unique design because there's no corrective mirror or corrective lens in the front. It's just open body. So, which makes it really nice because then I don't have to worry too much about cooling down the big mirror. It cools down fairly rapidly or heats up fairly rapidly so that I don't have problems with temperature variations across the mirror to warp it, to change the light path. I mean, the telescope itself, though, the back mirror is parabolic, so it's ground differently than the hyperbolics of other telescopes.
Okay, so are those photos licensed? Are your photos licensed?
No, they're just mine.
No,
they're not licensed.
We wish to use it for our wallpaper, for our computer.
I have a presentation that I give to a area for our schools. So we go out and give presentations to the local schools, and I bring along a slideshow that 67 slides of different areas that I have photographed from the Horsehead, Horsehead, North America Nebula, M42, M45, Andromeda, M31, M33, M101, M103, I'm sorry, 101, 106, 105, and 104. Yeah, these are all pictures I've taken of
including supernova,
Well, I have supernova remnants, M1. That's a supernova remnant. That's a picture that I had within my slideshow here. Oh yeah, and the planetary nebulas, M27, M57, and the helix. I got the picture of the helix. Oh, helix is beautiful. It's green and red. It's a beautiful picture. I'm really impressed with it. I impressed myself a lot with the pictures.
Wow.
Because I didn't
Listening to
expect
that,
to get.
yeah, we wish to invite you to specially present to us your photo in our English TAO class in the future. Is it possible? Just for this photo
Yes.
shooting.
That slideshow that I have that I present to the students, it's 500 megabytes, so I can't email it. It's too big. It's 500 megabytes long.
Oh,
it's big.
Wow.
It's
So
very,
Bill,
very big.
Bill, you can post a few good photos in your Facebook, and the people can download from.
Oh
there.
yeah, they're on Facebook. Yeah, there's a number of them on my Facebook page. Yes, there's in fact that's probably most of them. No, not most of them, but they're quite a number. Yeah.
Yeah, then we will add you in our Facebook.
Sure.
Okay,
Go ahead.
thanks.
Yeah,
Great. Okay. Yeah, all right.
Yeah, you can
Thank
do
you
that.
so much.
I also got pictures of trains from Taiwan too.
Okay, thank you so much.
From Ali Mountain.
Ali Mountain, yeah.
Sorry, Lecturer Krause. There's one person who's raising their hand, Diana Sakura. Do you have any question for Lecturer Krause?
Thank you.
Yeah, that is my online name. But like, hi, Uncle Bill.
Hi.
I had a question about like, I remember part of it said that so like Tao is in everyone and everything. I know that this is more like a psychology route, but then like, what about serial killers and stuff?
What about what?
Serial killers and like stuff along the lines of that.
Okay, yeah, I understand what you're saying. Yeah. Now, remember one thing about the Tao. It's within us, yes. But does it control us? No. Our free will does that function. Now, we can take information from the Tao and apply that. Now, when I went to school, we had I had parochial teachers, nuns teach me, or taught me rather, that there's over on this shoulder here is the devil. He's sitting here sticking his pitchfork into my ear, yelling and screaming, yeah, go ahead, steal that piece of candy. Yeah, go ahead, copy that homework. No one's going to know. And over on this shoulder is an angel telling me or whispering to me, no, don't do that. You know that's not right. Now, it's up to me to listen to which one I want to listen to. The devil on this side yelling and screaming, or the angel whispering to me. So serial killers are listening to the devil. We as Tao members listen to the angel, because the angel is what gives us the inspiration to do good. And so these are just metaphorical stories, but nevertheless, I'll give you an example. If you have done something wrong, knowing that you've done something wrong, how do you feel? What is your feelings? You feel what? Guilty. You feel, oh, maybe I shouldn't have done that. Oh, maybe I shouldn't have cut that guy off on the freeway. Oh, maybe I should have helped that person when they wanted help. Or do you listen and how do you feel? You feel guilty. Now, you do something good. You say, wow, I helped that person. I've given that person something that he or she can use. How do you feel? You feel good about it. You feel great. You feel, hey, I should do this more often because it is something that I enjoy. I like this feeling. I don't like feel guilty about something, but I do feel that I have done something good and I feel good about it. So now that's the Tao. That's the Tao in us. What do you want? You want to feel guilty or do you want to feel good? Serial killers, people who are criminals, don't want to listen to the Tao. They don't care. They just want to do what they want to do because they're more into the materialistic world. We go a little bit beyond that. We look beyond the material. We look to each other. How can we help other people? How can we give them what we have? How can we help them to achieve what we know now? So that's the I hope that answers your question, that we as a human being have this free will. We can choose and decide which direction we want. And if we follow the direction, that's why Tao is called the direction or the path. We follow the Tao, we follow the correct path, we then will be able to achieve our goals, our merits. We will then continue after we pass and cross over. We will then continue with that. So that's the idea behind that. So, okay, I hope that answers your question.
All right, yeah. Thanks, Uncle Bill.
Thank you. You're quite welcome.
Lecturer Krause, can you let us know your Facebook name? Can you type it into yourself?
Bill Krause.
Bill Krause. Okay.
Not hard. Not
also,
difficult.
I'd like to just say something. I'd like to. There are many people here from England as well. So the lecturer Zhang from England actually asked a lot of the members over there and also members from Thailand to take part. So I just want to say thank you. And if you'd like to share anything, any lecturer from England would like to share anything, thank you very much.
So would you like to
Thank
share?
you, Derek and Claire.
Hello, hi.
Hello, hi. Hi, Reverend Pong. Hi, Bill Krause. We did join your class once a month, and because of the timing issue, sometimes we didn't turn on the camera. And thank you very much for letting us to join your class as well. And thank you, Derek and Claire, for today's opportunity for us to join your class as well. And I do realize that I asked my TAO member here, and we just worry about we have the capacity problems, like we have only limit to 100 persons. So we asked them to join the YouTube. So they are actually at the YouTube watching the channel. I think maybe they left already, I don't know. So thank you very much for today's class. We enjoy very much. I think if we have a questions or something in future, we probably send you a personal message. Lecturer Krause. Yeah, we asked you during the class in Los Angeles class.
Sure.
There will be link for us, but I'll make sure that I send out the message.
If anyone has question, you can send question to the Facebook of Bill.
Oh yeah, we can. Okay, I'll make sure that I add you in.
He's gonna have hundreds more Facebook friends.
Yeah, John likes
I'm going to be inundated with questions now. Okay.
I'll try to find you and add you now.
I'll try and answer them all.
Right.
I will try and answer them all. Okay. Do you have any questions at all right now, though?
Bill, can I ask your photography? Do you employ time lapse photography? Oh, you do, right?
Yes, I do.
And how long is the time lapse?
I have one I've done that has lasted 8 hours. Another one that was about 6 hours. Another one that lasted 2 hours. But the presentation was only something like 10 seconds. So it's the rising of the Milky Way. It starts up like this here and then rises up like this. So, and it took me 2.5 hours to do about 10, 12 second video. So, and I shot that, there are 240 exposures. So it took me about 10 to 11 seconds to show the whole thing. So,
okay. There are only very specific spots.
I do time lapse, but they're very time consuming. Yeah.
Right. And there are only very specific spots on the earth that you can take that, right? Only very specific spots, right? Okay.
Yeah,
Right.
yeah.
Okay, thank you.
They can get really extensive. The one I shot
Right.
was the one of clouds moving across the sky. It took me almost 8 hours to shoot
Right.
that.
Okay.
Because clouds move very slow.
Lecturer Krause, we have another member who raised his hand. Anub from, are you from India or?
Sir, sir, I am from India, from state of Assam.
Okay.
So, sir, I am very happy to listen to the lecture of sir. So I want to ask you one question. What is the relationship between the Tao Te Ching and the quantum of physics?
Between the Tao Te Ching and the what?
And the quantum physics.
Quantum of physics.
Okay, this is another lecture.
Quantum mechanics. No. Okay, let me think about that. Now, the Tao Te Ching addresses everything in the universe. The quantum mechanics addresses everything in the subatomic particle era. All right, so anything doing with the electrons are on their own. There's nothing smaller than an electron. You can't break it down to a smaller particles. Whereas protons and neutrons have smaller particles within them called quarks, and mesons and bosons and other smaller things. Quantum mechanics deals with that. Now, and that only, it does not extend past the nucleus of the atom. Now, the Tao Te Ching goes from the absolute center of that atom all the way to the far ends of the universe. So the Tao Te Ching encompasses everything, because it does address what the Tao is. It does address that. And the Tao is all encompassing. It's everywhere. It's the creator. It is everywhere, and it's a controlling function. Now, the quarks, there's six different quarks, but they all have different names and different functions, and yet the Tao is what put them there in the first place, because of their actions, because of what they do, because of their movement. That's also a part of what the Tao is. Okay, so the Tao Te Ching addresses what we can hear, see, smell, blah, blah, blah. Okay, so it takes care of the 6 senses we have, the 5 senses of the human body and the 6th sense of taking that information and making it into something intelligible so that we understand what it is. Because remember, all of the functions of our senses are strictly chemical stimuli. It does not know anything. Something's got to determine what are these things that are striking it. We hear something, our auditory nerves hear that, make a response to it. They vibrate because of the vibration of the air, and yet it tells our brains, what is this sound? What is this thing? Our brains, our wisdom, our intelligence determines what it is. What is that sound? Oh, it's the sound of a bell, or it's the sound of a car, or it's the sound of a bird, or it's the sound of nothing. So there is a stimulus there. Now, the Tao encompasses all that and encompasses everything in the subatomic particle era of the quantum mechanics, or it's quantum mechanics, quantum physics, pretty much the same thing, but it's defined as quantum mechanics. So, well, but there's no mechanics involved with that. There's nobody turning wrenches on it, that's for sure. But they call it quantum mechanics. Okay, did I answer your question?
Sir, we are forming an organization, Taoist Foundation of India, for the first time in Assam.
What? I'm sorry?
For the first time, we have formed our first time in our state, we have formed the organization Taoist Foundation of Assam, Taoist Foundation of India. So, sir, we want to invite you. Is the COVID is over? So we are very happy if you come to Assam, our state. Thank you, sir.
Well, I don't know about that. I don't know about that, but who knows? Things happen. Things happen. Maybe I can get with Eric or Joseph Taiwan, Eric Lin, and I can get with them and we can come over and see them. Who knows? I don't know. I have no idea. We just have to play that one by ear and wait until all this coronavirus has dissipated so that we can get back to normalcy, get back to being a normal society. Okay. Okay.
Okay. Thank you. Also, we have. I remember we also have a tea master from Belgium here. Milan, I don't know if do you have, Milan, if you're there or not. Do you have any questions you'd like to ask or? Okay, maybe not. So, but is there anyone else who would like to take this opportunity to ask any questions?
Silence.
Silence. Okay.
There's silence here.
Yep. I guess it's about time to wrap it up then. So thank you very much. Wow, I learned there's so much information. It's very inspirational. Thank you. I definitely, you guys are our inspiration as well. Thank you very much.
You're quite welcome. It was my honor to do this for you. It really is. I mean, yeah, I'm using these words, but deep down in my heart, I know that this is good. And I really appreciate my sharing of my small amount of knowledge to everyone. And it's much appreciated. Thank you so much.
And also I give you a suggestion. Whenever you visit Las Vegas, please give Bill a call. He can make excellent coffee. Excellent coffee.
There it is right there, Peter.
Yeah,
I got it right
coffee.
here.
Yeah.
David, Lecturer Wong.
We
also need to ask Lecturer David Wong to share. He's here. David. He's behind the scenes too. He's very humble. He never.
Yeah. Yeah. Thank you, Bill. I also like the coffee. Oh, one day I go to Las Vegas, I can enjoy your coffee.
Yes, indeed.
Indeed.
Anytime.
Yeah, that's really a good lecture. Yeah, this evening, especially about the universe and also the beautiful photos you take. I'm not sure why. If we remember, if we read the history, we know that the ancient people, for example, the Babylonian or the Sumerians, they can survey how it is astronomy, but I'm not sure why we cannot see so many galaxies. But those old people, they can see that. Maybe some gift were taken away by the God because of some unknown reason. But although I'm trying to understand, to know more about the universe, but I think it's an ongoing discovery of the universe, just like what it could be before the Big Bang, or how it will be after so many years. I'm not sure about that, but just like cultivating Tao, it's just like a path. Just what Bill highlighted. It's just a path. It's just a way that we follow the way. We follow the path. One day, ultimately, we reach the point to reach the Tao. Thank you, Bill. Thank you for
thank you so much for your kind words. I appreciate that. Thank you so much.
Yeah,
and as far as what happened before the Big Bang, I have no idea. What happens after today, No idea. It's speculation. That's all it is, speculation.
Yes, that's correct. And really nice to see so many friends from many countries, just like Ingi from England and Azul from Mexico, and so many friends. Nice to meet you online. Yeah, nice to meet you online. And waiting to see you next time, next month. So all the best. Thank you, Bill. And prepare another topics. You will have another one very soon.
Oh yeah, we'll
I do think like your Facebook will be blowing so many friends join.
Oh yeah,
for sure.
Yeah, and wish you all the best, and all of you a very nice weekend.
As a hint, I have another lecture that is based on this one, but it's the spiritual reality. It's a spiritual idea of what can we exist without Tao, a spiritual existence. So I've done that. I've written that lecture to follow up on this one, and maybe if Clear and Derek will allow me, I can give that lecture also, but not next week, not next month. Let me give me some time.
How about November or December?
Yeah, that would be okay.
Oh, that's great. That's great.
Yeah. So this worked out real well. I thank you so much again for everything.
We are looking forward.
Definitely.
Yeah.
Okay.
Thank you very much, Bill. Thank you. Went wonderfully. Thank you.
You're quite welcome. I do appreciate it. Again, I am honored by giving this lecture and this presentation to everyone. I was very impressed with the number of people who actually were listening to it. So that's great.
Just to point out, there's still 50 people on YouTube. So we've got 47 here and 51, so 100 people still here.
Wow, that's a lot of people.
Yeah, but today YouTube have at least 200.
Yeah, 200, over 200. So 200 on YouTube, 200 on Zoom. That's a.
Yeah.
What about Facebook? Did you have?
Yeah, Facebook. I think some people.
Yeah, so like 500. Well, that's that's a lot.
A lot of people.
Bill, after this lecture, you will be famous.
You already famous.
No, I'm not famous. No, infamous maybe, but not famous. I just I have a passion to do this. It's something that I feel very strong about, and to be able to express my thoughts and my ideas about what the Tao does for us, for me, and for us, and for everyone. So I just want to share this with everyone. So this is my feelings. And if I can use this vehicle to do that, well, so be it. I will do that. So that's why I became a lecturer almost 20 years ago. So or took the vow of being a lecturer almost 20 years ago. So I feel honored and humbled at the same time to be able to make these kinds of presentations. And again, I thank you too, Peter, for allowing me to do this. You are, like I said, an inspiration and almost a mentor, because you were the one who started all the English presentations and English meetings in 1995-6 area. So you're the one who did that. You were the instigator. So I blame you for everything that happened since then.
Yeah, we're also really glad to have an English Tao member like you, who can become the bridge between the Tao and the English-speaking people. You have done a great job. Yeah.
No, thank you so much. I do appreciate that. It makes me feel good.
So next time, make more coffee for me.
Make more coffee. Okay.
Yes.
You
Yeah,
come
would
up,
you like
have the
to
coffee
Oh,
later.
for sure, for
Yeah,
sure.
for sure. So which topic you would like to share, Mr. Peng?
Oh, for me, I think I regret I stayed for too long. I think my breakfast. Yeah.
Okay.
We can talk about that later, but
okay.
give a topic in the future. But I can do such a good job like a Bill. Yeah.
Much appreciated.
Thank you so much.
Thank you so much.
Thank you, Peter.
Thank you, Bill. Thank you, everyone.
Thank you, Mr. Peng.
Yeah, thank you.
Okay, thank you, Derek and Claire and
morning,
Robert.
good afternoon.
Okay, everyone.
All the
Bye.
best. Nice weekend.
Okay,
Nice
bye-bye.
weekend. Bye-bye.
Okay, I'm going to
Thank you,
hang up
everybody.
now. I'm leaving.
Okay.
Okay.
I leave it. Bye.
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 See you,
See ya.
everybody.
Bye.
You guys next
Bye.
time.
I'm out of here. I'm gone.
All right. See you,
Bye.
Bill.
Take care, Robert. Take care.
Yeah.
Take care now. Okay.
Yeah.
Everyone, have a good day. And may the Tao be with you always. Thank you.
All right.
Bye.
Thank you, sir.
Cheers.
Okay.